Hi all, in this video we are just going to see and learn about bag of words. So bag of words is basically the NLP technique, which is basically used for feature extraction with the textual data, and it simply gives you a idea about the occurrence of the words within the document. It doesn't matter about, or it ignores about the grammatical details and the word order or anything like that. So it's just a bag of words. I mean, like, it doesn't matter or bother about the order or the structure of the details, right? And where exactly the word is in the document doesn't matter. So it just gives you about the bunch of the words that occurs within the document with along with its occurrence, right? Actually, bag of words could be done in two different ways. One is by doing the pre-processing technique, another by not doing the pre-processing technique. But I will just show you a small example with the pre-processing technique, how to do it. Say, consider that you are actually taking two different sentences. Welcome to the NLP learning. Now we start learning. Now start learning. Learning is a good practice. So these are the two different sentences. So what we does is that we convert the sentences into lowercase, and then we can remove the characters. So these are all the pre-processing techniques that we actually stop words removal. So all those things are basically done. And then what we have done is that we have actually put the data into vocabulary. So see here, so welcome to is actually gone. So great is there. So great, instead of this great, basically it is NLP. So it's the welcome NLP learning, now start, good practice. So these are the words. So you have made it into a vocabulary, and you are simply, as in the cosine similarity, we are just finding out the occurrence of each term in the sentence. That's all. So we are not doing anything, we are just vectorizing them. So this kind of a technique which is actually part of your cosine similarity, if you could see. So so this is the first step. So you are just taking the bag of words and finding out the occurrence and converting it into a vector. So this is exactly what you are basically doing in the bag of words, right? Now we will see the demo for the bag of words using different techniques. So in this we are going to see about the various implementations. So the first one is that the detailed way of doing things. I mean, like making up the function and then doing it, and everything you're doing from the scratch. But normally people will not recommend this for the detail, because we do have a lot of libraries with different bag of word functions and libraries, which were we could directly use them, and which gives more efficient effects than the one which we do it from the scratch. And so this is just a function, okay, which takes the list of the words. So we are actually taking the tokens, and our aim is to produce the vectors, right? So you have to actually go through each and every word in the filtered vocabulary. And what you will do is that you will append those vector by taking each word at the time and its corresponding, and this vector will be filled with the count of each of the tokens, right? So this is how our loop is all about. Then you are actually, so this is your definition of the vectorized tokens. Then you are actually taking the sentence. So when you take the sentence, it just returns the list in which the order remains the same, no item repeats, and using the set function. It's actually using the set function. So once it is seen, then you will call it as, I mean, like say sometimes some word will be repeated multiple times, right? So that's why. Okay, so for x and x in the sequence, if not seen, then you will put it in the scene, or seen or add, then you have to add it right in the scene. So this is what you will be doing. So, and then you are also using the stop word. Specifically 2 is a, and you can add as much as possible, or if you want to include all the stop words, that is also possible. But here we are specifically using these 3, okay. And then the special characters also, we are just restricting it to a certain bit. You can use everything. So we have 2 different strings which are given. Welcome to NLP learning, now start learning. Learning is a good practice, right? So we are converting into, these are all the pre-processing which we are actually doing. So converting it into lower, then we are splitting it into tokens. Then when we print the tokens, we will get both the tokens printed here. And then you are actually calling unique of tokens 1 and tokens 2, right? Then you are printing the vocabulary, okay. So this is the initial part. And then the next one is, so you could see here, so the first printing is printing all the tokens for both the ones, and then you are actually printing the vocabulary. So here this is the vocabulary, okay, which is actually printed. And then you are actually filtering the vocabulary, right? And filtering the vocabulary, and you are actually taking one word at a time and actually converting into a vector. So for that we are actually using vectorized function. So we are vectorizing both the token 1 and token 2. So hence you will get 2 different vectors for the document 1 and document 2. Okay, so this is how you are actually doing it. So here the main thing which you have to understand is that this is a normal way of doing things, and you are actually keeping, okay, so this is a simple way of actually doing things, and but we can also do it by using the sklearn. There is a function called count vectorizer. So the count vectorizer function is from the sklearn library, and it is easy to implement also. So for that we have to import pandas. Okay, so pandas is a package which is there for working with the data frames and everything. So you are actually using the feature extraction. So this count vectorizer, this particular function is basically in the sklearn. It is actually part of the feature extraction functions, and that too for the textual functions, text, right? So you are actually using two different lines here, and you are actually count vectorizing both, and n-gram range here we are just giving 1. So that means that we are taking one word at a time. Okay, say if you want to take as phrases 2 words at a time, then you have to change it for bigrams like 2. So accordingly you have an option here for changing the number of the grams as well. I mean, like say if you are taking 1, then you are taking this is a, right? If you are taking 2 there, then it is taking as these is, then is a, like that it will be taken, right? 2 words at a time. Then you are actually fit transform is basically the main function where you are actually applying this particular function upon the sentences. So you have vectorized them, and then you are actually applying them, and then you are actually converting it into a data frame, right? So data frame, and then you are actually converting it into a count vector data frame, and you are actually printing it. So if you look at here, so all those other everything is actually restricted, and you are getting like good job and miss, right? So these are the main things which you get. And for the document 1, what are there? So all the 3 of them are actually present. For the document 2, actually you have good, right? But other 2 terms are not there. So this is how actually you will find out the bag of words, how you will actually vectorize the tokens after pre-processing using the sklearn count vectorizer function, right? And then we can also use it by NLTK package. So NLTK package, so these are all simple, like it's just saying like you have to import the necessary, then you have to define the list of the documents, and you have to tokenize, remove words, and create a vocabulary, initialize the Bo dictionary with the word counts, and then you have to filter the tokens, increment the count. So this is all something which you already know, so this is nothing great or new in it. So it's just they have I mean, like I have given this so that it will be easier for you to understand, that's all. So here we are actually using the NLTK package, so that's the main thing which you have to understand. So here we are actually downloading the Pinkett and stop words and everything from English, and then we are also using the word tokenize and the counter. So this is from collections counter, right? So in order for us to count the number of the tokens, so that is what we are doing. Then we are actually giving this documents. I love natural language, so these are things which are there in the documents. Then you can actually use the word tokenizer, and you are reducing it into lower. Then you are actually removing the stop words, and you are filtering everything by using all the 3 in it. So that is how you will get the filter tokens. Then you are actually putting them into a dictionary as a set, right? And once the set is ready, then you are actually calling like word is equal to 0 for all the word in the vocabulary. And for that, what you have to do is that we have to count the word occurrences for each token in the filter tokens, and then for each word in the token you have to of word is equal to of word plus 1. So that is how you will actually add it. Then finally you will get the bag of word representation like this. So here when you look at the bag of word representation, you will get it like each word, like language, love, and everything corresponding to its particular I mean, like the number of the occurrences. So this is how word, and for each word you will get the, so this is how you will get, right? So this is the representation that you will be using. See, this is your bow, right? So in your bow, it's like a key value pair which you have actually represented. So after this one, you will start getting each of your bow, right? Each of your bow is nothing but this dictionary representation, a key value pair. So that will be actually represented to you. So this is nothing but the implementation of bag of words. So we have seen the bag of words by using the regular basic function by writing it from the scratch, and then by using the count vectorizer function from sklearn, and also the NLTK package. So in NLTK package, you have this word tokenizing, vocabulary of finding out the vocabulary, and then using it, and filter tokens. You're just it's still easy, but you have to break a little bit more onto it and understand what is actually happening. So if you have all this code and everything with you, you can actually tweak it and use it for your project also. So that's all about the bag of words. If you have any doubts or any concerns or anything, you can always get back to me. Thank you so much.